If you thought the last part was crazy, you haven't seen anything yet. So we're going to be porting the DACs now from Sonic 3D Blast to Sonic 1. Now, this wouldn't be too bad if you were hacking Sonic 2 or Sonic 3 even. Because, well, I have to get into a little background history for you. So, Sonic 2 and 3 store the DAC samples just as part of the ROM, just on the cartridge. And so you have all the room in the cartridge to put these things. Sonic 1 doesn't work like that at all. Sonic 1 keeps its DAC samples in Z80 memory. Now, in case you don't know, the Mega Drive has two CPUs. It has the 68K, which can see the whole cartridge, and it has its own RAM, 64 kilobytes of RAM, I think, which is a lot, all things considered. The Z80, on the other hand, is a little coprocessor used by the Master System, and on the Mega Drive it's used more for sound stuff. It can only see 8,000 bytes of the cartridge at a time, and it only has, I think, 2,000 bytes of RAM. So like I said, Sonic 1 keeps its DAC samples in Z80 RAM. You only have 2,000 bytes, and well, for Sonic 3D Blast and its vast array of DAC samples, that's probably not good enough. So we're going to have to convert Sonic 1's sound driver, let's just call it that, to support DAC samples being on the cartridge, not in Z80 RAM. But perhaps I should show you the simple way of people who aren't modding, hacking Sonic 1. So here's a Sonic 2 disassembly, and right here is its sound driver. Now, in here somewhere is a table of DAC samples. Here we go. Actually, is this what I'm looking for? Yeah, good enough. So you have one table here. And this table has, let's just call them IDs and pitch values. I'll explain what these are in a bit. But yeah, you have IDs and pitches, and these IDs reference another table. And this table references bank pointers and sample lengths, and this table references data in the cartridge. So if we just come to the main Sonic 2 file, you can see that that table from earlier references the sound data directly, and that's it. So these samples are included together in what's called a Z80 bank. Remember how I said the Z80 can only see 8,000 bytes of the cartridge at once? Well, this is it. This is the start of an 8,000 byte slice of the cartridge, and this is the end. And so, yeah, all the drums have to fit in one of these. I mean, you can fit them in multiple, depending on how flexible the game engine is, the sound engine is. Sonic 2 is not that flexible, it only has one bank, but we could probably modify Sonic 1's driver to have multiple, which I think Sonic 3 does. And Knuckles and 3D Blast, they all have multiple DAC banks. So, if you want to port DACs, if you wanted to port DACs to Sonic 2 or 3 or whatever, just add a new bin include, a new couple of labels, and come like here, update this table or the Sonic 3 equivalent, and then if there's a third table in Sonic 3, update that as well, and you're good. Just make sure you fit in the Z80 banks and so on. Sonic 1 is nowhere near that easy, so we're going to be spending the first chunk of this video doing the Sonic 1 way. So, we know that this is the sound driver, right? Well, not quite. S1.sounddriver.asm is only the 68K part of the sound driver. It has a second part written for that other CPU, the Z80, and this is its code. Now, Z80 codes in a different language to 68K, so yeah, it took me a year or so of me being a Sonic hacker to eventually learn Z80 assembly, which is slightly different. Well, it's quite different, to be fair. So, when I first started planning this video, I was going to say, oh, why use this when you can just replace it with Mega PCM, which is a custom Z80 sound driver portion for Sonic 1 that already does the whole reading DACs from the cartridge thing. But then I realised, well, the entire point of these videos is to show you how to port songs without just replacing the sound driver. We're trying to port Sonic 3D music to Sonic 1, not a custom Sonic 1 sound driver that someone else made. So we're going to be doing this the extra hard way. You're in for one hell of a ride, folks. So, where do we begin, huh? So as I said, this is Z80 code. Z80 code goes in Z80 RAM most of the time. And like I said, the samples are in Z80 RAM as well. So if you scroll past the code, oh, would you look at that? It's the DACs. So we're going to be changing this big time. We're going to move this out of here and into the main ROM space. Yeah, which is this. And I'm sure we can just put them wherever. Let's just put them like here. So yeah, we need to modify this sound driver. So rather than reading from this file, let's just say, it reads from this file. Now it's not as easy as that, it's not as simple as that, but that's the most abstract way to break it down. So yeah, just delete that, put it here, and let the games begin. So where do we begin? Oh, Nelly. Again, Sonic 2 and 3 don't have this issue, and personally I don't recommend using Sonic 1's driver. Yeah, I don't recommend porting it. I mean, if you're hacking Sonic 1, I guess you might as well, but yeah. So, yeah, does this look familiar? Remember how Sonic 2 had an offset, a length, and a pitch? Don't mind this is just padding. But yeah, this is the same. So, here's your Sonic 1 equivalent to those 3 tables or so from Sonic 2. But remember, Sonic 2 had extra data. It has these. Oh no, sorry, I'm going a bit bananas. Never mind. But yeah, what we're going to do is we're going to change these pointers to, rather than referring to Z80 RAM, it refers to an offset in the Z80 bank. Yeah, this is going to get a little weird and a little complicated. So I think to start with, we're going to just begin by porting some very useful, or copying some very useful macros from the Sonic 2 disassembly. Let's just hope I found the right file for them. We're going to want something that converts a cartridge address to a Z80 bank address, and we're going to want macros for defining the start and end of Z80 banks. So here's one. Yeah, we'll just start with these. So you can put them in the Sonic 1 disassembler's macro file, but I'm just going to put it here for now. So we're going to want to start a bank here. Let's just call it DAC bank. And after our DAC samples, we're just going to put a finish bank macro. I wonder if this will assemble. It won't run at all, but let's see if it assembles. Okay, that's fair, yeah. So as I said, we need to convert this, because now ZDAC sample 1 refers to a location in the cartridge, not in Z80 RAM, so it doesn't really agree with this weird size data directive, mnemonic, opcode, whatever you want to call it. It's complicated, so we're going to need a macro to convert it, again, like I said, from a cartridge address to a Z80 bank address. Now surely Sonic 2 will tell us what we need. Here we go, we need this ZMake 68K pointer. Now where is it? Here we go. Alright, and we're just going to take this and... okay, maybe we should start using the macro file. Fine, whatever. We'll just shove them at the top. Who cares? Alright. So now we take this and we're going to wrap the addresses with it. Now we shouldn't get build errors, but again, the code won't work. Symbol double defined. Okay. I didn't know the Sonic 1 disassembly had this, but fine. Okay. Apparently that macro's already in Sonic 1. I don't know why. Maybe it's for the Sega sound? But yeah, there we go. So the ROM has built, and the ROM's gotten a bit bigger too, which is... oof. It's because the stuff that goes in Z80 RAM is stored on the cartridge at first, but it's compressed. But because we've moved the DAC samples, which are very big by the way, out of Z80 RAM, they're no longer compressed on the cartridge, they're just raw. Which is why the ROM has gotten bigger. Just some trivia that you might like to know. So, we've got it kind of mostly working. The Z80 driver now does correctly point to the proper location in a Z80 bank. The samples have been placed in a Z80 bank, but we haven't told this thing where the bank is. It doesn't know which 8,000 byte slice of the driver, of the cartridge, has these samples in it. And considering how many samples Sonic 3D Blast uses, we can't fit them all in one bank, so we need to say which sample can be found in which bank. Let the games begin. I think the first thing to cover is how you select a Z80 bank. And for that we can just look at the Sonic 2 driver. It has some code in it somewhere that handles switching Z80 bank. Like, unlike Sonic 1, Sonic 2's driver is 100% Z80 code, not just partially. So naturally this game, in order to read anything off the cartridge, has to do a bank switch. Right, here we go. Yeah, this seems familiar enough. So essentially what you do is, it's a pain in the ass really. You take the address of the bank, you divide it by 8,000, and then one at a time write the value to a register 9 times, each time shifting the value so that you pop out the low bit and replace it with the bit after it and so on. It's like a serial port as opposed to a parallel one. I don't know, I'm not a hardware guy. But if you do that 9 times to the bank register, you will successfully switch the bank. And then everything from, I believe, the 8,000th, from address 8,000 to address 10,000 will be that 8,000 byte of cartridge space. This is what people had to deal with in the late 80s, early 90s. Good grief. So this is it, bank register 600. Suppose we can just borrow this. So I suppose we're going to have to find the code that reads that little table we just saw, and then add in some logic for switching bank based on what it finds. Yeah, that looks about right. Ah, never mind, we already have a bank register. Equate. Cool. Yeah, again, if you edit in Sonic 2 and 3, you don't have to do this. You just pop in the file and edit a few tables. This is just Sonic 1. This is about as bad as it gets, folks. Okay, yeah, I guess we can start here. It's at this point that the IY register points to the appropriate member of this, the appropriate area of this table. So let's just say, yeah, we can split this into 2 bytes and have the first byte here be the bank number. So that would be IY plus 6. Okay. So let's come to this table logic. LD A IY plus 6. And now A contains our bank variable thingamajig. We're then going to load, I think HL is unused. Load the bank register into HL, and we're going to do that thing I said where you write to it 9 times, shifting after each write. So LD HLA followed by, yeah, I think that's it. Do that. I think we can use a rept for this. So repeat 8 times, because we need to do it 9 times, and this first one here has already done it. Well, actually, when I say it like that, let's repeat 7 times. So that's the 8th, and the last one is a 0. Or actually, is that even? Nah, sorry, I'm just trying to remember the syntax of this stuff. Okay, yeah, now I'm just straight up Googling this stuff, so yeah. Like, if you're ever confused by Z8, you just look up the opcodes. There's a bunch of places that cover it. Like RA. Like, what's the equivalent that doesn't rotate, you know? Okay, yeah, never mind. Yeah, so 1, 7 to 8, and the last one, we're just gonna set A to 0 by XORing it against itself, and then write it. It's 9 bits, but A is an 8-bit register, and if you rotate it 9 times, then it's gonna loop, and we don't want that. We want the final bit to always be 0. So there we go. That should hopefully be everything we need. I hope so, because otherwise, then, I mean, if getting lost in my own words here, if it really is this easy, then we won't be doing DAC stuff for long, which is cool. So yeah, now we need to start doing bank stuff. So remember that macro we came across earlier? Make Z80 bank. Yeah, we're going to need this. So we're going to make the 6th byte just like the first 2, only this time it's using this macro. And yeah, we're going to do that for all of them. Now, maybe it'll build, maybe it'll even work. We'll just have to see. Unfortunately not. Oh, right, sorry. That rept we used earlier, I think you meant to do end R, maybe? Or end M, it's one of them. Actually, it was complaining about an open macro definition. End M, what the hell? Whatever. One more build, and then after that I'm gonna pause the video and figure out what the hell's going on. Oh, baby. I'm an idiot. Okay, well, it looks like we just fixed the issue and revealed another. Yeah, instead of using a rotation instruction, I could use like SRA, but unfortunately I don't think that's it's a slower instruction. It's like, yeah, if you're writing an assembly, make it quick. Alright, just going to extend a branch from short range to long range. Or a branch, should I say, from short range to long range, and a ROM. Alright, let's check it out. Hope it works. Alright, cool. Well, that was actually a lot quicker than I thought it would be. So we've now converted the Z80 driver, the DAC driver as most people call it, to read the samples from the cartridge. And yeah, it's working great, so that's nice. So, on to actually porting the rest of the DAC samples. That said, however, this is kind of gross. I mean, look at all this duplicate code, this logic repeated over and over and over again. I'm pretty sure I could put together a macro that would make this stuff simpler, especially when we're going to have like 80 samples instead of just 3. Yeah, I'm going to look into that real quick. Okay, here we go. So this is just a quick macro I've put together. And as you can see, it really simplifies defining individual samples. This is a little bit of trickiness I've had to do because of some cheat the original game does. We're going to be weeding this out though. Because yeah, while this is good and all, while reading through the code I did notice an issue. Namely how timpanis work. But there's also an issue of the way the Sega sample works. Check this out. Drums start at the number 81. And I suppose there are 6 samples: the kick, the snare, the timpani, and the other 3 or 4 timpanis. But yeah, anything above that, the game will just play the Sega sound. So I'm thinking maybe we make it FF rather than whatever number it currently is. Yeah, it's a bit of a shame this driver's got a couple of hacks in it. So if we look up the Sega command, you can see it tries to play sound 88. So like I said, let's just change that and play FF. And then we come back here and we're going to change this logic. So if it's FF, play the Sega sound, otherwise play drums. And yeah, I think that solved one issue, but that still leaves the other issues. Timpani, I think. I'm going to double check if this needs correcting or if we can just leave it as is. Good grief, this code is so gross. It's all hacked up and not good for general usage. So I'm here in DAC update track, and if you scroll to the very bottom, you can find the logic where it handles the timpani. Like I said, the timpani plays at various notes, various keys. The proper way to do it is to have multiple ones of these. Sorry, let me get this out of the way. Multiple ones of these where they use the same sample but different pitch values. And instead with Sonic 1, they've just hacked it in so this number gets patched because it's in RAM, you can edit it, and yeah, it's really stupid. It is really, really stupid. So to explain what's so wrong with this weird technique about having, what was it, everything above 88 being the Sega chant and the timpanis being this. The problem is it's hard-coded nonsense and it's fragmented. Look how it detects whether it's a timpani or not. It checks based on whether the 3rd bit is set, so if my understanding was right, that means, yeah, A8 to AF, sure, but then 98 to AF, then A8 to AF. It just ruins half the sample slots and takes them up for no good reason. So like I said, the proper thing to do is unify it all. Don't do this crap. Like, if we just look at SMPS to ASM. In an SMPS song, you only have D snare, D kick, and those are represented by numbers. So if we come here, we can see the numbers. They start at 81, then there's 82, 83, then 88, 89, 8A, and 8B. Now, this is stupid. But still, the numbers are 81, 82, 83, and so on. So there are 7 different numbers. But then you come here, and it does this tomfuckery, and then we come here, and now there's only 3. And it's the numbers, I think, are 81, 82, 83. 88 through 8B aren't even here anymore. So, like I said, the proper thing to do is have this table match well, this table, basically. But again, like this stupid gap where it just goes from 83 to 88 is done. We're going to get rid of that too. So let's begin with the yeah, okay, let's do this, right? Here we go. Here's our timpanis. I want to come here, and here's a list of timpani tempos. Now, I'm pretty sure these are never used, so ignore them. We only want these four. So 12, 15, 1C, 1D. Alright, seems simple enough. 12, 15, 1C, 1D. I think my memory was right. So let's get rid of that. And this is our proper table. Now we can ditch this disgusting, horrible code. 83. Like, it just converts everything to 83. It's horrible. Get rid of this. And then get rid of all of this. And there we go. One less horrible hack in our code. Now, just want to clean out an unused variable. There we go. Don't need that anymore. Now, we should be able to come to SMPS to ASM and change it to this. And there we go. Now it's 81, 82, 83, 84, 85, 86 and 87. And of course, come here and it matches to this. 81, 82, 83, 84, 85, 86, 87. Sorry, that should be a C. Right, there we go. Yeah, okay. So now everything should be okay. The driver is now ready for new samples. And they're all going to work, hopefully. So, I suppose we'll just en masse copy every Sonic 3D sample rather than mess around and... I don't know. It's just, I want to keep this video relatively short. So, where is it? Can I get all this junk out of the way? Alright. So here we have a list of DACs all from Sonic 3. And Knuckles and 3D and so on. Okay, so once again we're going to make use of Flame Driver because we're going to appropriate its Sonic 3D Blast DAC data. So as you can see we have a table just in the middle of this mess describing the DACs. Now, since we're porting Sonic 3D songs, we want to keep an eye out for ones that are used when this is used. So all of this is used by Sonic 3D. None of these are used by Sonic 3D. This is Sonic 2. Here's some ones that are exclusive to Sonic 3D and not just all three games. And yeah, keep scrolling and you're going to find more data. Like Sonic 2, this has multiple tables and so on. So here are the banks from Sonic 3. Oh, well, from Flame Driver. And as you can see, again, it includes data if it's Sonic 3D. That's just Sonic and Knuckles and 3D. Sonic 3 and Sonic and Knuckles, that's just Sonic 3. And this is more shared stuff, more non-3D stuff. I guess these are used by everything. Every game. This is Sonic 2 or... yeah, whatever. Okay, so we're just going to start copying everything, really. Now, if you want to support Sonic 3 and Sonic and Knuckles songs, I guess copy all of them. You know, go ahead, but... ah, jeez. It's just a lot of copying and pasting, you know. So, let's start. Take this. Now we are going to have to convert it to our little format. But yeah, we'll get there eventually. So I'm just going to skip things that aren't used by Sonic 3D because we only want Sonic 3D right now. Okay. I think that's it. I think. And now we just want the samples they use. So remember, the data goes in here. Right, that's not used by 3D, that's not 3D. This is 3D. So one more for collection. not 3D. I guess this is 3D. Everything seems to use it. Am I going crazy? Like, what is going on here? I'm just going to double check real quick. Okay. And, oh, I'm an idiot. Nah, never mind. Okay. So we don't need that. This is Sonic 2 or Sonic 3D. That's Sonic 2. This is Sonic 3D. Okay, that should be the last of it. It's just that I don't really think there's a Sonic 3D disassembly with all this stuff in it, so you have to just get it from Flame Driver. Flame Driver just has everything in it, but like I said, we're not porting that driver today, so... we could convert it to this format, or we can just get lazy and borrow whatever the heck this macro is. Let's see. Length, pointer, bank. No thanks. Okay, well, never mind. Let's just get on with this. So as you can see, the structure's a bit different. So the pitch is, well, that's 68K. This is Z80 notation. There's a start label but no end label, and the name of the macro is different. So I'm just gonna go through and yeah, just edit it, make them suit our custom macros format, and yeah, just that for all of these. See you in a bit. Okay, this should be good enough, unless I've made a mistake somewhere. Now, we're not done here, particularly with these pitch values, but we'll be back later. So, now it's just this. So, we're not going to bother with this include stuff, but essentially what we're just going to have to do is copy, come here, end, and yeah, oh, and also change DAC include, just include. Do that for all of these so that we have a matching end label for every start label. Okay, this ought to be sufficient. As you can see, I've just added end labels to everything. Cleaned it up a little, reformatted a little, but besides that. Okay, now I think this should assemble. Well, actually there's one obvious issue. There's no way this is all going to fit in one bank. But, well, we'll see. Ah, okay, I'm an idiot. Yeah, I'm going to actually need those samples, so we just copy the whole folder, I suppose. It won't affect the ROM. The ROM will only use what it wants to use. It's just, I don't know. Yeah, do whatever you think is best. Yeah, I guess we're just going to have to change the paths of every file. Great. This is where copying, like, replace comes in handy. So, let's see. Just select the lot and replace. That better work. Here we go. The bank must fit in 8,000 bytes, but it was actually, yeah, that. So now we just come down, grab the finish bank, and I don't know, put it here, and scroll back up to the top. Let's give it a unique name. All right. And yeah, we're just splitting the bank into two. Essentially, these markers, they don't actually do anything. There's no assembly code in them, but they are like little warning scripts for the assembler to tell you when a region of data that you claim to be within one bank is not within one bank. Essentially, the point is that it will detect and prevent a sample from crossing the boundary between banks, because if they do, yeah, when you're playing the sound and it reaches the end of the bank, it'll like loop back around to the beginning and play garbage data basically. So you have to make sure you do not cross a boundary in the middle of a sample, which is what these are for. So we just keep moving it around until we find the optimal place. The line, the boundary between banks. It looks like I found it. Okay, look how much bigger the ROM's got. But yeah, if you properly space your banks, you'll save space. Otherwise, you're wasting space on padding. Okay, so that just leaves one more thing. Well, actually two more. But let's just get it to play. So this is where things get unfortunate. Remember how we added the PSGs? Well, we've got to do that again, but with the DACs, and we're doing more screwing around, unfortunately. So take everything that is under Sonic 3 or whichever game you're porting from and stick it here. But keep in mind, you do have to synchronize them properly. So at the start here, it's not 81, it's timpani plus 1 because it's after the final timpani. And then we need to find more things that are used by Sonic 3. Take these. D-kick. Oh, sorry, ignore that. Yeah, okay. Yeah, like I say, this stuff's confusing. Hopefully this is good enough. Hopefully you understand what I'm doing here. So they're linked to each other. So this is attached to this is attached to that. And yeah. So if now we come to Volcano Valley, right, well, I have to go grab fresh copies, but if I revert these back to normal without replaced PSGs or DACs or anything, they should work. So Green Grove Zone 2 and Volcano Valley Zone 2, I think. Alright. Let's quit out and build. We have a working ROM. Well, we have a ROM. But let's see if it's a working ROM. Oh, Blastem can just crash. Great. Thanks, Blastem. Great, now my pause button isn't working. Right, and I'm back. So let's check out that Green Grove. Well, I don't know about you, but that sounds pretty good to me. Let's try Volcano Valley. Of course, the FM instruments are still broken, but... yeah, it's too bad I chose the one song that seems to use nothing but the... okay, never mind, that sounds pretty good. So you had that snare, that cymbal, you had those snares or whatever the hell they were. So, yeah, alright, cool. We're 40 minutes in, but we finally ported the DAC samples. But there is one more thing we unfortunately have to deal with, and it's not very easy at all. You see these pitch values? They're different between different drivers. The faster a DAC driver is, the higher these numbers have to be for them to sound the same. Now the best I can recommend to you is listening to a copy of Sonic 3 and then listening to your ported songs and just checking if the drums sound the same. If they sound too low, lower the number. If they sound too high pitched, make the number higher. Every number needs to be offset by the same amount. So if the snare needs +2 to sound proper, every sample has to be +2 to its pitch. Now in fairness, there actually is kind of a way to automatically correct these numbers, but they're too complicated. They're too complicated for the average Joe to do. It requires knowing exactly how many CPU cycles the DAC loop takes, and yeah, it's ridiculous. It's better to go by ear, I suppose. But yeah, I don't really have a very good ear for these things, but that snare and the kick, everything sounded okay. So I guess we can leave these as is for now, but again, if you're not satisfied, yeah, every number needs either adding 1 or 2 or 3 or subtracting 1 or 2 or 3. So besides that, yeah, we have ported DACs, PSGs. That just leaves those broken instruments. And well, I hope you didn't burn out on editing code in the last part, because oh boy, we're editing code more now. So let's double check that error message, huh? Voice at blah 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 has TL bits that do not match its algorithm setting. This voice does not work in S1, S2 drivers. Hahaha, I wrote that error message. Haha. So, this one's hard to explain, really. Essentially, Sonic 1 and 2's drivers make a very odd restriction on what an FM instrument is allowed to do. And the instruments that make these little errors are doing stuff the driver doesn't let it. Sonic 3's driver has no problem with letting it do these things. So, yeah, we have to remove this limitation ourselves. I believe the responsible code is called set voice. Here we go. Here we go. Now, I think this send voice TL. Maybe this is it. Ah, man. Yeah, you see this little table here? It doesn't exist in Sonic 3. It doesn't use a table that limits what you can and can't do. It just kind of calculates things dynamically. So let's see, this gets put into D4 and yeah, here we go. It checks if this bit is set or if that bit is set, and if it is or isn't, it adds the volume to the sound, and yeah. Sonic 3 doesn't do any of this. Well, it does do this, but it doesn't use a table for it. It doesn't use a table that you access using the algorithm byte. If this is going over your head, don't worry. Even I don't know how FM actually works. I just know how the sound driver does it. So once again, you read D4, start reading it one bit at a time and skipping values if it is or isn't this or that. Pretty weird. Now I'm just going to go to the equivalent code in Sonic 3 and show you the difference. What allows Sonic 3 to use these instruments and what doesn't allow Sonic 1 to use them. Okay, I believe I've found it. So this is send voice TL, whereas in Sonic 3's driver it is Z send TL. And what we're looking at here is this loop. So we read a byte, check it. If it is negative, then we add the volume, strip the sound bit, and send it to the FM chip. And then we loop. And there's this code. We read a byte, check if this thing we read from the table earlier is set or not. If it is or isn't or whatever, add the volume to it, branch on overflow for whatever reason, and then write it to the FM chip. So what matters is the fact that this check that skips adding the volume is to do with reading or manipulating the data we read from that table, whereas in the Z80 code, the check is done based on the high bit of the instrument data. So that's what we're going to do. So it's the one that has the data added to it, and in this code, it is D1. So yeah, we're going to do, I suppose, a BTST. I'm going to test the 7th bit of D1 if it is not set. Come on now. If it is not set, send TL. Okay. So we don't need this junk, we don't need D0, don't need any of this anymore. So we can just get rid of that. Okay. And then there's another area that does it somewhere. I swear I was there earlier. Here we go. So we just do it again. So we do BTST where we test the high bits. Ah, actually no, I've got a better way. BTST is slow. Do TST.B to D1, and if it's positive, branch. That should emulate the original code a bit better too. branch if positive, branch if positive. Alright, so let's come back here, and yeah, just do a tst.b on d1 if that value is negative, sorry, if that value is positive, branch. So we don't need that. Where do we get d4 from anywhere? Yeah, we don't need you, don't need you, don't need you. Okay, and then we don't need this table anymore. Cool. Alright, now what? So hopefully the broken instruments work now. We just need to disable that little warning in SMPS to ASM. It's in here somewhere. Here we go. Yeah, voice it, yada yada yada. If sound driver smaller than 3. Okay. Yeah, we need to go a bit further. Okay, so things are getting a little funky. SMPS to ASM is trying to determine what to do with the FM instrument data depending on the sound driver you're using. But we're not really using a driver it knows about, we're using a customized Sonic 1 driver that behaves a bit like the Sonic 3 driver. So we need to start hacking up this code to suit our needs. So even though this is checking for the Sonic 3 driver, our Sonic 1 driver behaves just like it. So we could add a check, like if it equals 1 or it equals or greater than or equal to 3. But since we're not going to be using this customized SMPS to ASM in any other drivers, we can also just remove the check entirely, since we know what Sonic driver version we're using. It's 1. Well, not even that's too relevant, but yeah, so again, remove the Sonic driver check, because actually, yeah. So this should be safe. Yeah, so if we build it, let's check what errors we get. Just warnings that don't really apply to us. Okay, so has this helped with those instruments we encountered earlier in Volcano Valley? Well, okay, unfortunately not. It seems to be another issue, but now that I think about it, yeah, this instruction's pointless because of just how the 68K handles its flags. So, yeah, just a bit of trivia. If you want to optimize your code, keep these tricks in mind. Okay, well, I haven't really had any leeway figuring out what's up with Volcano Valley. Maybe it's some other engine quirk I'm actually not familiar with. But I did notice 2 bugs. When you turn on the game and the whole Sega thing happens, it says Sega twice, so we need to deal with that. But also, sound effects are broken, I know why. By manipulating how FM instruments work, we've, to a degree, changed their format. Remember what I said about how we have to convert all the game's music to ASM so that they properly adapt to any modifications you make? Well, this applies to sound effects as well, so we have to install ASM sound effects. This is what I covered in the last video. Just grab the sound effects, pop them in, and then just change the includes, sorry, the bincludes to includes and the .bins to .asm. So I'll get back to you when I'm done with that. Okay, well, turns out that was only part of the problem. Yes, our modifications to SMPS to ASM and the way this is handled does mean you have to convert the sound effects to ASM. But there was another problem. If you played sound CF, it would sound horribly broken. It's got nothing to do with our modification. Not directly anyway. Our modification just exposed a bug in the sound driver. So if you come to the end of send voice TL, scroll up, and you'll see this. And these, like Control F, you'll find a bunch of bugs. This driver's full of bugs. So yeah. It says right here, this is the wrong voice. It should have been A5 instead of A6. So change it to A5 and sound effects will work again. Now, bizarrely enough, fixing this bug and converting, improving FM instrument compatibility did not fix Volcano Valley. Sorry, this is beyond me. Even I'm not really sure what the hell's going on there, if it's not an FM issue, if it's not... Well, actually, I mean, I don't think this thing uses note fill, so it's got nothing to do with those other warnings. It seems to be just another one of those bizarre little differences. I even tried checking if it was the note rest duration thing, and I couldn't really... I didn't seem to get any results there either. I tried making it so it had the same behaviour as Sonic 3, but it still didn't work. Okay, well, actually, doing some checks myself, there are bits of music data that should invoke the note rest duration bug. Remember what I was saying about Sky Sanctuary Zone? This song's riddled with them. So theoretically, there should be issues here. Now, I'm wondering if Flame Driver can deliver. Because one of the things it supposedly does with the improved music files is it avoids this problem. Oh yeah, would you look at that? I'm searching and it ain't finding any song data that will produce that bug. So maybe let's just replace the original Volcano Valley with the bug fixed version and see if the song works. Well, I'll be damned. That worked. Yeah, cool. Well, I take it back. Use the improved music because, yeah. Now, originally, I wasn't going to edit the music data because I felt like that was a hack, and I did actually try, and like I said, I tried to edit in Sonic 1's driver, so it handled note rest duration, the same way as Sonic 3, but it seems like I messed up at it because it didn't work. But yeah, okay, cool. So there we go. Ported Volcano Valley, I've ported Green Grove. I've been listening to them for a while, they sound fan. Let's try one more thing. Death Egg Zone Act 2. That is a song that I know for a fact has an FM instrument that doesn't work with Sonic 1's driver, so I'm going to quickly add that. See you in a bit. So nice, you have to say it twice. Right, so just going to go to Scrap Brain and... Oh, actually, is this the wrong one? Nah, I think this is the wrong one. Right, well, I'll get back to you when I actually have the right song. Okay, so what we're keeping an eye out for is right before the song loops. If you just hear static in the audio, then I've done a bad job. If it doesn't play static, then we've done it right. So it's about to come up now, I think. Now, that is. Yeah, okay, good. One of those instruments would normally just make a horrible hissing sound, but no, we've improved Sonic 1's driver enough to support these unusual FM instruments. So cool, there you go. I've demonstrated compatibility with Sonic & Knuckles music as well as Sonic 3D, and yeah, okay. I think that leaves one issue. Let me double check. Well, I mean, of course, there's the Sega stuff. We'll get to that in a bit. Okay, so there are two more issues I want to cover. One is the Sega chant repeating. That was just a stupid bug I caused. This used to be down here, and then I moved it up here. And, well, that was a mistake because this line is important. So, put this back here, and there. Now the Sega chant works. There's another issue. There's another two issues. I realise I haven't shown how to port a coordination flag, which is unfortunate. I would have thought something like that would pop up already. But there's another issue. I know, these issues just keep coming out of the woodwork. But if you try and use certain Sonic 3 and Knuckles songs, you are going to bump into a rather annoying issue. So if we... let's use Chrome Gadget. If we build the ROM now... Here we go. Universal Voice Bank does not exist in Sonic 1 or 2 drivers. So do you remember when I said... Remember when I said FM instruments were part of the music? I was wrong. Sonic 3 got very quirky and decided, you know what? so many of our songs use the same instruments, why not just put them in the driver? So they did, and certain songs use FM instruments that aren't even in the song data, and Chrome Gadget's one of them. So what can I tell you? Let me just quickly go over the format of an SMPS song again. So you can see right here, here's the header, and this part denotes where the FM voices are. As you can see, it says it's at this location. If you search, it points to that big list of FM voices, you see. However, in Chrome Gadget, notice it's a different macro. Rather than pointing to the voices, it just says this. Now there is something of a solution you can use here. Let's try grabbing it from here. So you go into the Sonic & Knuckles sound driver, look around. Okay, no. Right, this isn't ideal. They're in RAW format. You want them in SMPS to ASM format, you know, this. But, so if we, well, once again, we're pilfering Flame Driver. Flame Driver has Sonic 3 and Knuckles' universal voice bank in SMPS to ASM format. So just open it up and here you go, a big old list of voices. Now this isn't ideal, I admit, but, well, one solution is just copy the whole darned thing, right? I know this isn't a pretty idea, but, I mean, this is annoying. This is just a really annoying thing to deal with. So, SND, Chrome Gadget Zone, voices, and there you go, just paste it in the music data. Now obviously the song isn't going to use most of these damned things, but I mean the alternative is you go through the whole damn song and look for every single change voice command flag and then insert that voice and then change the number so that it refers to its new location, the new ordering in the voice table. And that is really annoying. So yeah, I'm just going to bypass that. Now in fairness, we could modify the driver to have a universal voice bank. Yeah, we could do that, sure. But at that point, like, what are we doing? Are we porting songs or are we converting a driver to be like another driver? Like, we got to draw a line somewhere. So let's see if that works. Yeah, sounds good to me. So, and if you want to get real funky and have a separate universal voice bank in the driver just like Sonic 3, then I'll at least show you what to do, kind of. We want this macro, right? Come into Sonic SMPS to ASM, and here you go, you have a macro. As you can see in Sonic 1, it is, that is not Sonic 1. In Sonic 1, it is an offset into the song and it's only a word long. You could convert this into an absolute address, if you'd like. Just remove that logic and yeah, change it to an absolute address. Then go into the driver and change it so when it reads the song's header, it reads a long word and it's an absolute address rather than an offset. Then you can just put the voice bank anywhere in the driver, have the this macro point to it in here, and it will work. That's what I did in my clone driver years ago. But yeah, so that's the universal voice bank issue sorted out. So now you can put even more Sonic 3 and Knuckles songs. That leaves two more issues. Again, missing coordination flags, which for some reason I just haven't bumped into yet, and the tempo issue. I'm honestly not sure if I'm going to go over the tempo issue because these songs work, but Sonic 1 has a worse algorithm for measuring song tempo. So some songs will play back slightly quicker or slightly slower, I think. And yeah, the solution to that is to like port over the tempo algorithm from Sonic 2 or 3. And I don't know, this video is long enough as it is. That said, I can think of maybe one example of missing coordination flags, but the trouble with that is it's not really something I can cover in this video, because the coordination flag I'm thinking of is so complex that I actually can't port it. I've never ported this particular one before. Yeah, here we go. Yeah, sorry, this is what a missing coordination flag looks like. And it wants the SMPS mod change one, and yeah, this one relies on an entire subsystem that doesn't exist in Sonic 1 and 2's driver, where you can modulate the FM channels. You can't do that in Sonic 1 and 2. So in order to port this coordination flag, you'd have to port the whole FM modulation system with all of its volume envelopes. Yes, envelopes, the same things as the PSGs. Like, you really want to port all that stuff. So, I mean, if you're crazy enough to, go ahead, be my guest, but I don't think I'll be covering that today. You can go the hodgepodge method and just get rid of them, you know, if that's your kind of thing. I mean, even guys like me have to hodgepodge it sometimes because there's just a limit. You can only port so many songs, but this is what I mean when I say coordination flags are devastating. Like, at least DACs and PSGs can be ported relatively willy-nilly, even if it does take 2 hours or 1 hour, whatever. But coordination flags, especially not this one. I would show you Carnival Night running without this coordination flag, but it wants some DACs I haven't ported, and I don't want to go through the rigmarole of porting them. So, I think that's the last thing off the list. You know, the bytecode differences I've dealt with, missing instruments I've dealt with, missing coordination flags I'm afraid I can't be too much help with. Sound driver behaviour differences we have kind of gone over, but yeah, as far as is reasonably possible, this is what you can do. You know, you can port Sonic 2 songs, you can port Sonic 3 songs, most of them anyway. You can port Sonic 3D songs, for the most part anyways. Now, if you were to port, say, music from Knuckles Chaotix, you're going to be in even more trouble, because that thing uses a fourth type of instrument, a PWM instrument, which is an instrument exclusive to the 32X. So unless you want to add 32X support, you know, to Sonic 1's sound driver, you aren't porting those songs. So, yeah, don't think that just because, you know, these videos exist, I suppose, or you just have good know-how, that you can port any song to any game. It's really, really not that easy. SMPS is kind of a horrifying nightmare mess, but then again, what did you expect for a video game console from the 80s, you know? So, that's it. I hope this was useful. I know, you know, folks, especially newcomers, just love porting music from Sonic 3, and then bang their head into a wall when they realise just how complex it is. But yeah, so you don't need to install custom drivers. Not all the time anyway. You know, you can port Sonic 3 songs to Sonic 1. What's so wrong with Sonic 1's sound driver besides everything? But yeah, so hope this has been useful. I hope I've taught you something about the Z80 and all of its weird intricacies, SMPS, PSGs, DACs, and so on. And yeah, see you next time.